So the title of this section is Applications and Models, and so that it implies that you actually know everything that you need to know, and now it's just about making it work into word problems and things like that. So in this first video, it's basically just triangle stuff. Later on in this section, we'll do a little bit different stuff, but remember, trigonometry is basically the study of triangles anyway. So we don't know how to deal with anything except for right triangles. So, that's what you're going to be looking for. And most of these are set up. It should be pretty obvious how the right triangles. And some of them give you guys pictures, but others don't. So if they don't, make sure that you're drawing it out, drawing the situation out and labeling everything correctly, and then just thinking through some of the stuff that we've talked about in this chapter. And sometimes they're not going to give it to you straight up, and you're going to have to, create your own. And so, I'm just looking at number 11, and they give you this picture of this isosceles triangle with both of these being theta, and they want the altitude. And so you're going to have to draw yourself an altitude that would be right here. Okay, and so then there's your two right triangles, and so then you can play around with it like that. So look for right triangles. Maybe you got to drop some lines down to make some right triangles. Read the problems a couple times, and try to label them the way you think. So I'm going to just pick some problems out to do in this first group of problems. Pay attention to what I've put down. You're definitely welcome to go on. Again, there's nothing new in this section. It's just applying the stuff that we have already we've already thought about. So, here's a pretty simple one. The first group of problems are all going to be, relatively straightforward. And so here's the problem. Again, make sure you draw yourself a picture and label it. So we have this situation where we have a 100-foot line attached to a kite. So here's our kite, and that's 100 feet. The angle of elevation is 50 degrees, and we're looking for the height of the kite. And so that would be properly labeled. And again, this is really straightforward, right? We're just thinking of SOHCAHTOA. That's our sine, cosine, and tangent ratios. And, pay attention to what we are given. We're given a hypotenuse, so right away you should be thinking either sine or cosine. And then we have the angle here. We're given the opposite side compared to our angle. And so then that means we are dealing with sine. So then it's sine of 50 degrees equals the opposite side over the hypotenuse. And so then that means our height, we're just going to multiply by 100. And so then 100 feet times the sine of 50. Make sure your calculators are in the right mode, right? We're in degrees here. And, right, you just type that into the calculator, and you get that the height of the kite is roughly 76.6 feet. Okay, so here's the second problem I chose. And, I picked this one because of the way it's worded. Now, this one has a picture already for it, but I think it was 31. They kind of word it the same way. Well, I guess I give you a picture on 31 also. But, this is kind of a little bit confusing. And so luckily they gave us a picture here. And so this is a very common problem with triangles or really distances in general. We're looking for this D here, right? And finding the distance D of the fire from this line. And so we have these two different right triangles, but the problem is, what makes it different from that last problem is that they're only giving us this length here. Okay, so we have to manipulate it just a little bit. And what I'm going to do is I'm going to call one of these distances from one of the fire towers to this perpendicular line. I'm going to call one of them X. Now, it doesn't matter which one you call X. I'm just choosing this one here as X. And then what that means then is our other length, right, from A to this perpendicular line has to do with the 30 kilometers that is between the towers and minus this little X from here to here. So right, what we're doing is if it's 30 kilometers from here to here, and then we're saying, well, this is a value X, we're not sure what it is, then this length from this line segment here, D, to A has to be 30 minus X. Okay, and again, like I said, it doesn't matter when you're doing these kind of problems which one of these you decide is X and which is the given length minus X. It doesn't make any difference because it'll all work itself out, especially in this problem because we're looking for this height here of D. So now what we're going to think about is setting up what we can, okay? Like, when you're doing these kinds of problems, you can only do what you can do. So what we have now is two right triangles, and let's just look at this one first. We have this right triangle, we have a degree, and we actually have two lengths now. Now, just because we don't know what these variables are doesn't mean we don't know what these lengths are. This length is 30 minus X. This length is D. So we can actually set up another trig ratio problem with that information. So, make sure you're using the right one. We do not have hypotenuse, so that means that we have to deal with tangent. So for this left-hand triangle, we're going to say, okay, this is tangent of 14 degrees, and that equals opposite D here over 30 minus X, right, over our adjacent, opposite over adjacent. Okay, and so the problem with this right now is that we have two different variables in one equation. And that should really trigger the idea of system of equations for you. So for every variable that you have, you need a separate equation for it. So we have two variables. We got to come up with two equations. Lucky for us, we have another right triangle here. And again, we have a 34-degree angle. We don't have the hypotenuse, so we're thinking of tangent. So now we're at opposite over adjacent. So our second equation is going to be the tangent of 34 now, 34 degrees, equals that same D, and now that's over X, right? Opposite over adjacent again. And as long as we have as many equations as we have variables, then we should be able to solve it. Okay? Just because we have tangent in here, don't make this any harder than it is. This is just some number. It's not anything else besides some weird number. Okay, so, we can solve by, I would suggest doing substitution on this because of the ratio we have here. And so you could solve for X, you could solve for D in either equation. I think that the easiest equation to deal with is this one here. There's no wrong answer and no wrong choice. You could be over here. And I personally am going to just solve for D up here. So I'm just going to multiply by X, and then we have D equals X times the tangent of 34. You're welcome to change tangent, of 34, punch it in your calculator and find out what it is. I'm just going to do all that at the end. What we just did is, there we go, is set this up we have D. Now we can come over to the other equation and plug D in there. So then I have tangent of 14 degrees. And instead of D up there, I'm going to put X times tangent of 34. Okay? Now, it's not super straightforward just because we still have a ratio with x's, but this actually turns out to be not too hard of a problem. What I'm going to do here first is multiply both sides by 30 minus x. And so then I'm going to have tangent of 14 degrees times 30 minus x. I'm going to leave that. I'm not going to distribute it. And I'm going to have that equal to x times tangent of 34 degrees. Then I'm going to divide both sides by the tangent of 14. So then I have 30 minus x equals x x times tangent of 34 degrees over tangent of 14. Again, you're welcome to change these into numbers. I don't like to round before I need to, so I'm just going to leave it there. But, you know, really what we have over here, I'm going to do a little side thing, right? This side, so you don't get confused on this next step, this is just some number times x, right? Like it would be, you know, it could be the same as, you know, some number x. So then we're just going to divide by that some number. Or we could divide by that that number. But, you know, that might get a little messy over here. So instead, what I'm going to do is divide by this x and leave this some number. That some number, again, is tangent of 34 over tangent of 14. So I'm going to divide everything by x. You could do this by factoring, but, you know, what I see is that the reason I think that this is an easier thing than getting terms together and factoring is because I know that x divided by x is going to be 1, and so that's going to actually cancel out my other term with an x already. So definitely, if you'd rather factor, that's another option. But I'm going to divide everything by x. Remember, if you're dividing, you do have to divide everything by that thing that you're dividing by. So that means we're going to get 30 over x minus 1 equals this number that we don't really know yet. We're still calling it tangent of 34 degrees over tangent of 14 degrees. And then I'm going to add 1 to the other side. And so then we have 30 over x equals tangent of 34 degrees over tangent of 14 degrees plus 1. Okay, and so now we do have something pretty easy at this point. You can think of cross multiplying. I'm going to actually change this now into a number. And, you know, I'm going to leave it in my calculator, so I'm going to round it when I write it down, but I'm going to leave it in my calculator as unrounded so that I can get as close to the answer as I can. So then what we have is 30 over x equals roughly 3.71. Okay, and so now we're just going to multiply by x. And so then we'd have 30 equals 3.71x. And so then x equals 30 divided by 3.71. And so that is going to be roughly 8.09. And we're talking about kilometers here. Okay, so now be careful on these problems because we got to make sure that we answer the correct thing. And what we solve for is x. So let's go back up to the top here. all we did was find x. But the problem wants us to find d, okay? So just be careful, don't get ahead of yourself. But we have a nice easy equation. Oops. We have a nice easy equation here. Shoot, hold on. Touching all kinds of wrong things here. We have a nice easy equation here. D equals x times tangent of 34, and we just solve for x. So let's go down there, and we can figure out what d is. So we're going to say 8.09 times the tangent of 34 degrees, I think is the one I had. Yep, tangent of 34. Okay, and so then that, oops, sorry about that. So that distance, d, is right around 5.46 kilometers. Okay, so none of that is really difficult, but it's putting a lot of things together. I'm going to do one more problem that's going to be very similar, and then I think you guys can handle that first chunk of problems. Okay, so this is number 38. This is a pretty cool problem, I think. We're talking about a height of a mountain in miles. And so we have this situation, and the way I did it was to draw two right triangles. Okay, and so the first one is, we got the height of the mountain here. And we have the degree here as 3.5, the elevation. Right there. And then we have another situation after we drove 13 miles, right? The height of the mountain isn't changing, but this angle did to 9 degrees. Okay, and so then, like I said, it's very similar to the problem we just did. The only difference between these two things is that since we got closer, right, the angle of elevation changed, right? You're closer, so you got to look up higher. And so, well, what is the relationship between the only other thing that's changing here is that the distance is that we got closer. So, I labeled this X, and then after we drove 13 miles, we got 13 miles closer to the mountain, so that's X minus 13. And again, you can do this in the other way. You could set this up differently. You could say, oh, this is X, and then this would be X plus 13. So not quite as straightforward as the other one, but just be careful and think about what you're looking at. But now it's going to be very similar, right? We have two variables again. We need two equations. Luckily, we have two right triangles, and so we're going to set them up. We're going to use tangent again. So tangent of 3.5 degrees is equal to opposite over adjacent. Then the tangent of 9 degrees equals opposite over adjacent. Okay, and again, very similar to the other problem. I'm going to solve the easier equation for h, and so that would be this first one. So then I'm going to say that h equals x times the tangent of 3.5 degrees. And I'm going to substitute that into the second equation here. So that means it's going to be tangent of 9 degrees equals x times tangent of 3.5 degrees over x minus 13. And now I'm going to solve this equation for x, and I'm going to do it the same way. So I'm going to multiply both sides by x minus 13. I am not going to distribute. So then we have tangent of 9 degrees. I'm going to write it over here because I'm running out of room. Times x minus 13 equals x times tangent of 3.5 degrees. Then I'm going to divide through by tangent. So then I have x minus 13 equals x times tangent of 3.5, tangent, over tangent of 9 degrees. Okay, and again, you're welcome to change those to, sorry about this. Let's see. There we go. You're welcome to change these to numbers right now in the effort to keep it as accurate as possible. I'm not going to do that. But for the same reason, I can divide through by x. Again, factoring is definitely a good way to do it. But if I divide everything by x, I'm going to get x over x. Good grief. So x over x minus 13 over x equals this number. So again, that's 1 minus 13 over x equals this number. Okay, so don't get mixed up here. What I'm going to do is I'm going to, in the same step here, add this term over and then subtract this term. So hopefully that's okay with you guys. So then it becomes 1 minus this tangent of 3.5 over tangent of 9 equals 13 over x. And now I'm going to go ahead and figure out what 1 minus tangent of 3.5 over tangent of 9 is. Okay, so I got 0.614, we'll call it, and that equals 13 over x. I'm going to multiply by x. So 0.614, x equals 13. Divide by 0.614 and get about 21 point, we'll call it 18. Again, I always leave it in my calculator to be as accurate as possible. Same thing as the other problem. Be careful because that's not what we're asked for. We're not asked for how far away the mountain is. We want to know how high the mountain is, right? And so then we need, this was our height, so x times tangent of 3.5. So that's 221.18 times the tangent of, good grief, tangent of 3.5, right? That's our mountain height. And what we're saying is, as the mountain is about 1.29 miles. And so I think that's a pretty cool problem, right? Like, I mean, you're just driving down the road and you can figure out how high a mountain is. So give these a try, see what you guys come up with. Make sure you're asking questions.